What is AI security? Protecting AI systems and their valuable insights from attacks and weaknesses requires AI security. AI process integrity and confidentiality are crucial in a future that relies on AI for decision making and data processing. This definition discusses ways to improve AI security to safeguard insights, compartmentalize AI operations to reduce attack risk, and adopt a zero trust approach. Protecting the process of generating insights, secure the whole AI lifecycle, from data collection and model training through deployment and continuing operations, to protect the process of generating insights. Insight generation requires rigorous protection of AI system data and models that turn data into useful insights. Compartmentalizing AI processes. Use compartmentalization or segmentation to improve security in AI processes. This involves separating and restricting AI workflow phases. Protecting critical training data and model parameters helps avoid manipulation. Compartmentalization reduces the impact of breaches. A zero trust model. This security strategy implies no implicit trust, even for internal users and systems. By verifying people and systems continuously, this paradigm supports AI security. AI systems can be extensively assessed for trustworthiness, authentication, and authorization. Improving AI security through these key points involves leveraging AI itself. Machine learning for anomaly detection. With AI, complex anomaly detection systems can monitor AI processes for unusual behavior. This aids in security event detection and response. Behavioral analytics. AI can build baseline patterns and detect variations that may indicate security vulnerabilities by monitoring user and system behavior. Secure model deployment. AI can automate model deployment in secure containers, monitoring and restricting model access to authorized people and processes. Real-time monitoring and threat intelligence from AI-powered cybersecurity solutions help enterprises stay ahead of new threats and vulnerabilities. AI security is evolving to safeguard the AI lifecycle, insights, and data. Organizations can protect their AI systems from a variety of risks and vulnerabilities by compartmentalizing AI processes, adopting a zero trust architecture, and using AI technologies for security advancements. This ensures the trustworthiness and dependability of AI-driven insights. What are the types of attacks or risk against AI? AI security. It's essential to identify and address various types of attacks and risks that can compromise the integrity and reliability of AI models and systems. Data security risks. The AI pipeline as an attack surface. The whole data pipeline is vulnerable to assaults since AI systems rely on data. This comprises data gathering, storage, and transfer. Attackers can exploit these processes to obtain access, modify data, or introduce malicious inputs. Data security risks. Production data in the engineering process. Using real-world production data in AI engineering is risky. If not appropriately managed, sensitive production data could leak into model training datasets, resulting in privacy violations, data breaches, or biased model outputs. Attacks on AI models or adversarial machine learning. Adversarial machine learning attacks trick AI models by altering input data. Attackers can subtly alter visuals or text to misclassify or forecast. These assaults can damage AI systems' trustworthiness. Data poisoning attack. Data poisoning involves inserting harmful or misleading data into training datasets. This corrupts learning, resulting in biased or underperforming models. Attackers exploit AI decision-making to cause harm. Input manipulation attack. Real-time input manipulation assaults modify AI system inputs. Change sensor readings, settings, or user inputs to modify the AI's responses or actions. These assaults could stop AI-powered systems from functioning and may result in poor decisions. Model inversion attacks. Model inversion attacks reverse engineer AI models to steal sensitive data. Attackers use model outputs to infer sensitive training data, posing privacy risks and potential breaches. Membership inference attacks. In membership inference attacks, adversaries attempt to determine whether a specific data point was part of the AI model's training dataset. This can expose private data about individuals or organizations. Exploratory attacks. Exploratory assaults probe AI systems to learn their underlying workings. Attackers can employ searches or inputs to find vulnerabilities, model behavior, or proprietary information for subsequent assaults. Supply chain attacks. AI system development and deployment are targeted by supply chain threats. Attackers hack software or hardware to insert malicious code or access AI resources, including third party libraries or cloud services. Resource exhaustion attacks. Resource exhaustion attacks overload AI systems with requests or inputs, degrading performance or creating downtime. These assaults might decrease AI service availability. Fairness and bias risks. Decisions made by AI models can propagate bias and discrimination. AI systems may create unfair results or promote social prejudices, posing ethical, reputational, and legal issues. Model drift and decay. Data distributions, threats, and technology obsolescence can render AI models less effective over time. This threatens AI system accuracy and dependability, especially in dynamic contexts. Understanding these threats and dangers is essential for building AI security measures and reducing AI models and system vulnerabilities. How do we set up a process or standard to protect my business? We want to showcase and instruct the different types of standards that are currently in place. We also want to show how we can roll it out business wide. Current standards. ISO/IEC 27001 is the world's best known standard for information security management systems, ISMS. It defines requirements an ISMS must meet. ISO/IEC FDIS 5338, ISO/IEC/IEEE 12207 describes software lifecycle processes, and ISO/IEC/IEEE 15288 describes system lifecycle processes. While these lifecycle processes are broadly applicable to AI systems, they require introducing new processes and modifying existing processes to accommodate the characteristics of AI systems. SAM. SAM stands for Software Assurance Maturity Model. Our mission is to provide an effective and measurable way for all types of organizations to analyze and improve their software security posture. We want to raise awareness and educate organizations on designing, developing, and deploying secure software through our self-assessment model. How can we apply these standards to our organization? Standardizing processes. ISO/IEC standards provide a framework that enables the CTO or CIO to streamline and standardize processes within the enterprise, ensuring consistency and efficiency across technology operations. Enhancing information security. By implementing ISO/IEC 27001, the CTO or CIO can establish a robust information security management system, identifying and mitigating risks, protecting sensitive data, and ensuring compliance with legal and regulatory requirements. Ensuring quality management. ISO 9001 can be applied by the CTO or CIO to implement quality management processes within the enterprise. This involves setting objectives, monitoring performance, and continuously improving processes, ultimately enhancing customer satisfaction. Fostering a culture of continuous improvement. The CTO or CIO can utilize ISO/IEC standards to encourage a culture of continuous improvement within the organization. By implementing ISO 9001 and ISO 27001, regular audits and reviews can be conducted to identify areas for improvement and drive innovation. Facilitating international collaboration and partnerships. Following ISO/IEC standards provides a common language and framework that facilitates collaboration and partnerships with other enterprises. This enables the CTO or CIO to ensure interoperability, exchange of best practices, and seamless integration with partners and clients worldwide. Evaluation and gap analysis. Complete a complete evaluation and gap analysis of your present procedures and security measures. Determine where ISO/IEC standards and SAM may be used and improved. Leadership engagement. Obtain the support and commitment of senior leadership, including the CTO, CIO, and other important stakeholders. Their engagement is vital to organization wide acceptance of these standards. Customization and integration. Customize standards for your organization. Ensure easy integration into current workflows. AI systems' unique properties may need process adaptation under ISO/IEC FDS 5338 and 15288. Employee training and awareness. Invest in employee training and awareness initiatives to ensure team members understand these standards and their compliance obligations. SAM's self assessment technique helps teams learn software security best practices. Documentation and policy framework. Comprehensive documentation and rules outlining standards and processes are needed. This involves assigning tasks, documenting processes, and setting information security and software assurance standards. Methodical implementation and testing. Gradually establish organization wide standards and security measures. Test and validate standards to verify they are implemented correctly and satisfy goals. Continuous monitoring and enhancement. Implement regular audits and reviews to monitor compliance with the standards. Improve security, quality, and software assurance by identifying and fixing problems. Certification and accreditation. Consider seeking ISO/IEC 27001 certification to demonstrate your commitment to information security. Communication and reporting protocols. Establish clear channels for reporting incidents, quality issues, and progress updates. Scalable implementation across business units. Gradually expand the adoption of these standards across different departments and units. External expert collaboration. Collaborate with external experts or consultants proficient in ISO/IEC standards and SAM to guide the implementation process. How is AI used in security? Artificial intelligence, AI, is increasingly utilized in various security aspects to enhance threat detection, incident response, and overall cybersecurity. Here are some key ways AI is used in security. Advanced threat detection. Anomaly detection. AI identifies unusual patterns indicating potential threats. Behavioral analytics. Monitors user and network behavior for suspicious activities. Signatureless detection. Recognizes new and unknown threats based on malicious behavior. Network protection. Intrusion detection and prevention. AI quickly detects and responds to network intrusions. Firewall optimization analyzes network traffic to optimize firewall rules and identify vulnerabilities. Endpoint security enhancement. Endpoint protection. AI-driven antivirus and anti-malware detect and prevent malware infections. Zero-day threat detection identifies unknown threats by monitoring endpoint behavior. User authentication and access security. Biometric authentication. AI enables secure access using biometrics. Behavior-based authentication analyzes user behavior patterns for unauthorized access detection. Security operations optimization. SIEM enhancement. AI automates SIEM platforms' threat analysis, alert prioritization, and incident response. Chatbots and virtual assistants. AI aids security analysts in real-time incident identification and mitigation. Phishing and fraud prevention. Email security. AI analyzes email content and sender behavior to detect phishing and malicious emails. Transaction monitoring flags suspicious financial transactions and fraud indicators. Vulnerability management. Automated scanning. AI automates vulnerability scanning and assessment. Risk assessment. AI evaluates vulnerability severity and impact for prioritized remediation. Security automation and orchestration. Incident response automation. AI driven workflows automate responses to common security incidents. Orchestration. AI coordinates security processes for complex threat responses. Predictive analysis for threats. Threat intelligence. AI analyzes threat intelligence feeds to predict emerging threats and vulnerabilities. Physical security enhancement. Surveillance. AI powered video analytics identifies suspicious activities for improved physical security. Compliance and reporting automation. Audit and compliance. AI assists in automating compliance checks and generating reports to meet regulations. Secure software development support. Static and dynamic code analysis. AI analyzes code for security vulnerabilities during development. Continuous monitoring, updates, and training are essential to stay ahead of evolving threats. How does AI improve security? Artificial intelligence, AI, improves security by enhancing threat detection, response capabilities, and overall cybersecurity measures in the following ways. Advanced threat detection and real-time monitoring. AI analyzes data for unusual patterns and behaviors, enabling early threat detection. Real-time monitoring and alerts help identify and respond to security incidents promptly. Reduced false positives. AI minimizes false alarms, allowing security teams to focus on genuine threats. Threat intelligence and predictive analytics. AI processes threat intelligence data and predicts emerging threats, bolstering proactive defense measures. Efficient incident response. Automation accelerates incident response, including system isolation and patching. Phishing and zero-day protection. AI detects phishing attempts and zero-day vulnerabilities, enhancing email and system security. User authentication and access control. AI enables secure authentication methods and continuously monitors user behavior. Vulnerability management and compliance. AI automates vulnerability assessment, risk prioritization, and compliance checks. Security automation and physical security. AI driven automation streamlines security processes and enhances physical surveillance. Secure software development. AI identifies and mitigates code vulnerabilities during development. By harnessing AI, organizations strengthen security, respond faster to threats, reduce risks, and adapt to evolving cybersecurity challenges effectively. Will AI take over cybersecurity? Machine learning in cybersecurity and artificial intelligence in risk management are powerful tools that significantly enhance security measures and risk mitigation efforts. However, it's important to clarify that they are tools used by cybersecurity professionals rather than replacements for human expertise. Here's why. AI augments human expertise. AI enhances cybersecurity by automating tasks, improving threat detection, and reducing response times. Advanced threat detection. AI identifies sophisticated threats, including zero-day vulnerabilities and insider attacks, enhancing overall security. Behavioral analysis and continuous monitoring. AI conducts behavioral analysis, identifies unusual activities, and enables real-time threat monitoring. Efficient threat response. AI automates routine tasks, allowing security teams to focus on complex challenges and strategic decisions. Scale, speed, and threat intelligence. AI scales for data analysis, responds in real time, and processes vast amounts of threat intelligence data. Security orchestration. AI driven automation streamlines incident response and mitigation processes. Challenges and human expertise. AI faces adversarial attacks and cannot replace human judgment and ethical considerations in cybersecurity. AI augments human expertise in cybersecurity by automating tasks, enhancing threat detection, and improving response efficiency while addressing evolving challenges in the digital landscape. How can HP help? HP Hewlett Packard Enterprise offers a range of products and services related to security, managed services, and risk and compliance. Here's how HP can help expand its offerings in these areas. Integrated security solutions. HP can provide integrated security solutions that combine hardware, software, and services to offer comprehensive cybersecurity. This can involve bundling HP security products with HP managed services to create end to end security solutions.